For this lesson, we are looking at 2.1, analyzing loans, focusing on examples. And so for our first example here, we have Josie is negotiating with his bank. Sorry, Josh is negotiating with his bank for a mortgage on a house. He has been told that he needs to make a 10% down payment on the purchase price of $225,000. Then the bank will offer a mortgage loan for the balance of 3.75% compounded semi-annually with a term of 20 years and with monthly mortgage payments. How much will each payment be? So we need to figure out how much Josh will pay altogether. So how big is this loan going to be? And so we're going to use our loan calculator that I already have up here. But we have to first figure out what we need to start plugging into this calculator. So since this is a house and we have a down payment, we have to do a little bit of extra work here for what goes into the calculator. So the purchase price is $225,000. So I'm going to write that down. But he's going to make a 10% down payment. So he has to pay that 10% before he actually gets to, before they actually do the loan calculation. So since he's making a 10% down payment, I am going to figure out what that is. So 225,000 times 0.01 is equal to 22,500. And so then I'm going to take his house cost minus the money that he has to pay. And so I'm going to take the 225,000 minus the 22,500. And so the mortgage that he's going to get is actually going to be for 202,500. So now we can go to our loan calculator. So I'm going to plug that in for my loan calculator. So the 202,500. The number of payments, so he's doing monthly for 20 years. And so monthly would be 12 times a year for 20 years. So that's 240 times altogether. His interest rate is 3.75%. His monthly payments, we don't know. That's unknown. So we're going to get the calculator to do it for us. So we're doing monthly payments and our compounded semi-annually. So we need to do semi-annually here. So just a note, and this is going to be a little bit different than your investment calculator. I don't know if you picked up on it. Is this number of payments is based on what I'm paying, not my compounding, period. Okay, so when you're doing number of payments, you're focusing on how you're paying, not how you're compounded. I'm going to go to my options to make sure my dates are a month apart because that's how I'm paying, and we're focusing on payment amounts. Okay, I'm going to hit calculate. And the total amount that we have at the end is $287,411.44. So I'm going to write that down. So the total. So the amount that he has to pay, or did pay at the end, is $287,411.44. Now, just a note, so that's how much he's paying on his mortgage, but he already paid this 22,500. So I'm going to take that and add it on. So we got 287,411.44 plus the 22,500. So when it's all said and done, He has paid $309,911.44 if you include what he paid for the mortgage plus his down payment. Okay, so I did miss a question in here for this space here is how much will each payment be? And so his payment that he's going to be paying each month for his mortgage, so his regular payments, is $1,197.55. And then how much interest will Josie have paid? So his interest is equal to, and then this is the bar here, so total interest is $84,911.44. And that question's done. So Bill has been offered to the following two loan options for borrowing $8,000. What advice would you give him? So he's got his two options. He can borrow at 4.06% interest compounded annually and pay off the loan in payments of $1,800.05 at the end of each year. Or he can borrow 4.06 interest compounded weekly and pay off a loan payment in $34.62 at the end of each week. So we're going to calculate how much this is going to, or how much interest he's going to pay, or how much extra money he's going to pay for each option. So option 1, and then we'll do option 2. And so I'm going to go to my financial calculator. And so the loan amount was for $8,000. For the number of payments, we don't know because we don't know how long the loan is going to be. The annual interest rate is 4.06. The payment amount is $1,805. So the payment's going to be made at the end of each year. So we're doing yearly or annually. And my compounding is also annually. And I gotta go to my options and make sure that my dates are a year apart. So 10/01/2022. Go to my calculator, hit calculate, and he's gonna pay for option 1 an extra $1,000.23. Okay, for option 2, same interest, so I don't have to change that one. However, compounded weekly. So I need to change it to weekly, and we're being paid weekly. The weekly payments is $34.62. We don't know what the payments are going to be, so that's my unknown. And we're still, loan amount is $8,000. Go to my options. This time they need to be a week apart, so 10/08/2021. Go back to my calculator, hit calculate. And this time it works out to be $825.67. So in this case, looking at how much extra money they have to pay, option 2 is the better one. So it's option 2 because Bill will pay less interest. For the last example here, we have Athena's employer loaned her $10,000 at a fixed interest rate of 5.4% compounded annually to pay for the university tuition and textbooks. The loan is to be repaid in a single payment on the maturity date, which is at the end of 5 years. How much will Athena need to pay her employee on the maturity date? So this one you got to be careful with because how we enter into the calculator is going to be a little bit different. And so the loan amount is 10,000. We have the fixed rate of 5.4%. It's compounded annually, so I got to make my drop-down menus annually. For the number of payments, though, we're going to do one payment. Because again, we're doing one payment at the end of our loan. And then the payment amount, we do not know. And so how I make the calculator do what I want it to, I'm going to go to my options, and for the dates, I'm going to make it the lifetime of the loan, because again, I have my start date, but then my first payment isn't going to be made until the very end of this loan. So we're doing it 5 years later. So we got 10/01, and then 5 years later would be 2026. So let's try that again. 10/01/2026. Then I go back, I hit calculate, and we get an answer of $13,007.78. So the end of this loan, you'll have to pay $13,007.78. So in summary, a loan can involve regular loan payments over the term of the loan or a single payment at the end of the term. The same formulas that are used for investment situations are also used for loans with a single payment at the end of the term. An amortization table is a payment schedule for a loan with regular payments.